This video is on triangle similarity. I'm going to explain how to use triangle similarity to prove that triangles are similar. To prove triangles are similar. Notice I'm only using the one squiggle. That means I'm trying to prove them similar, not congruent to each other. So I won't have a lot of things that are congruent, but triangles are similar if they are the same shape but not necessarily the same size, but they do need to be proportional to each other. Basically, I need to be able to scale the triangle up or down, so I'm using a dilation. This is where it goes back to the transformations, dilations. So there are three ways to prove that triangles are similar to each other. The first one is the angle-angle similarity postulate. Now, this could also be angle-angle-angle, but you only need two angles to prove similar. So if you remember back to triangle congruence, we could not prove triangles are congruent just because we have the same angles, but we can prove that they're similar to each other because they would have to be proportional. So if we have two angles of one triangle are congruent to two angles of another triangle, so we have angle A is congruent to angle D, and angle C is congruent to angle F, then the triangles are similar. So we can state that triangle ABC is similar. So we use one squiggle, similarity, similar to triangle. Since we did A, B, C, we still have to name it the same way. So A has one arc, B has none, C has two. One, none, two. D, E, F. Triangle D, E, F. By angle-angle similarity. That is our statement. That is our reason. One way to remember that if you are given information like this and you're writing a proof, this given statement will have no fractions. So if you see congruency and you see no fractions, it's probably going to be angle-angle automatically. We can also have side-side-side similarity. So these next two you have to be very careful about because side-side-side and side-angle-side can also prove congruence. So you have to make sure you understand if you're proving similarity or proving congruence. So side-side-side, what you have to have is if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So we have the corresponding side lengths of two triangles are proportional, and if all three of them, so all three of the sides are proportional to each other, then that means that the triangles are similar to each other. So if we start with side AB, I'm going to highlight that because I can't mark them congruent because proportional means that they have the same ratio, as in 1/2 is the same ratio as 2/4, which is the same ratio as 4/8. So that means that it has the same decimal value. So segment AB, let's say it was proportional to segment DE. So if I really wanted to say that these triangles were similar, if I said that triangle ABC is similar to triangle, let's go with DEF again, I need to show which side lengths are proportional. So AB and DE go together because AB are the first two letters, DE are the second two letters. But if I want to do side, 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 I would have to show the other sides are also proportional. So I would then say side BC. If I highlight that one in pink because it's different, BC are the second two letters, EF are the second two letters. So I would say segment EF. And then I could also say that AC, so that was the first and last letter, AC, I'll highlight that one in blue, would be proportional, so first and last, D and F. So what does that really mean it'll look like? What does that mean that we will be given or we could state? So if they're proportional, that means that the two yellow ones, AB, length, not segment, length AB, divided by the length of DE, because that's the ratio, will be equal to the ratio of BC over EF, which will also be equal to the length of AC over the length of DF, because these are proportional to each other. All three side lengths have to have the same proportion. So that could be 1 over 2, 2 over 4, 4 over 8. But if you put them into your calculator and you get a decimal value, all three of these fractions will give you the same decimal value. So we could make ABC scale up to DEF and multiply all three side lengths by the exact same number, and that's how we would get your triangle DEF. So as you can see here, the difference between congruency and similarity, these say that the fractions are equal to each other, not congruent. So if you want side-side-side similarity, you'll actually end up having 3 fractions because these have to be proportional. They have to be proportional. So that means, so up here with angle-angle similarity, there were no fractions because there were nothing about the side lengths. But for side-side-side, if you have 3 fractions equal to each other, that's going to be side-side-side. So this is 3 fractions. So if you have 3 fractions, you should have side-side-side similarity. On side-angle side similarity, again, side-angle side could also be used for congruency. That's why we have to look for similarity. So on here it states that if the lengths of 2 sides of one triangle are proportional to the lengths of 2 corresponding sides of another triangle. So again, we're dealing with 2 lengths. 2 lengths are proportional. So that means we're going to have 2 fractions. Here we had all 3 lengths are proportional. That's why we have 3 fractions. Here we have 2 lengths, 2 sides. So we're going to have 2 fractions. But we also have, and the included angles are congruent. So we can't show that angles are proportional. Angles have to be congruent to each other. So if we want to show that triangle, let's go with ABC, is similar to triangle DEF again, we would need to show we have 2 congruent angles here. We have that angle ABC is congruent to angle DEF. Because we have that angle. The angles have to be congruent to each other. The sides have to be proportional. So then what would the 2 sides be that would make this proportional? On here, A, B, C, and D, E, F. So if we're looking at B and E, these have to be included. That means that these angles have to touch the sides that are proportional. So this segment AC does not touch that angle at all. So the first thing we need is the length of AB because it touches that arc. So AB would go with DE because A, B are the first 2 letters, DE are the second 2 letters. AB are the first 2 letters and DE are the first 2 letters. So if we look at DE, that also touches that marked angle. Then we also need to find the other side because that's only one side. That's the side. The angle's in the middle. We need that extra side. So the other side that touches that arc is BC because it touches that marked angle. So BC are the second 2 letters, B then C, so then E to F. And EF, if I highlight that, would also touch that angle. So those are the 2 that would be proportional. So we would write that yellow over yellow. So AB over DE is equal to the length of BC, pink over pink, EF. Now, if I start with the first triangle on the top, I have to do the first triangle on the top on the second fraction as well. So I did AB on the top and I did BC on the top. DE was on the bottom, so EF has to be on the bottom. Now on here, because we have 2 sides mean you should have 2 fractions. 2 fractions. We're going to use this to be able to prove that triangles are similar to each other.